Okay, good morning, Professor David J. De Los Reyes. Okay, it's September 15. The time is around, it's almost 3 a.m., September 15. Okay, my topic for this session will be alternating current machines. And we are now on lesson number 11. Okay, lesson number 11, long video format discussion, AC machines. Okay, let's proceed. So, for those of you who are following my channel under the long video format discussion alternating current machines, we are now on lesson number 11. And the title of lesson number 11, okay, we are in sequence, okay? Equivalent circuit diagrams of transformers. Okay, the last time around, we discussed on how to bring out or draw the vector diagrams of the different voltages and currents, okay? If the transformer got no load, if the transformer, what you call this, got a load which has a lagging power factor, or if the load on the secondary will be a load having a leading power factor load. For tonight, we will be discussing the so-called equivalent circuit diagrams of a transformer going to the primary terms or secondary terms, because under the study of transformers, there are calculations like the so-called short circuit calculation and open circuit voltage calculation. And the what you call this, the circuit diagrams that will be needed over there is actually the equivalent circuit diagrams referred to the primary, or the equivalent circuit diagram referred to the secondary, to simplify calculations. So instead of going going from secondary to primary, engineers have actually improvised already a method on how to simplify the calculation. So they take into consideration the equivalent circuit diagrams of both the primary and secondary. They merge it into one, so actually we could calculate some of the parameters needed in the open circuit voltage and short circuit calculations by just using the primary term values or the secondary term values, but the result will still be the same. Okay, let's proceed. Originally, the winding of a transformer or the circuit diagram of a transformer single phase, this will be the original circuit diagram that we have studied, right? This is the primary side, secondary side, this is the load. The parameters on the secondary side will be the voltage across the load will be V sub S, designated. S refers to secondary. The subscript S refers to secondary. Capital letter C with the subscript L, meaning the impedance load, right? And the impedance drops or parameters on the secondary is designated by R with the subscript S and X with the subscript S, due to the winding on the secondary. And the impedance drops on the primary due to the winding in the primary is designated R with the subscript P. So this subscript P here refers to primary. So this is primary. And this is the secondary, right? So from now on, if we see the subscript S, it refers to the secondary. So as you can see it, all the terms on the secondary are with the subscript S. S, this is S, and this is S. On the primary side, it's the same. The resistance of the primary, due to the resistance of the windings, is designated small letter r with the subscript P. This is X with the subscript P. Current I sub P, the current coming from the secondary side, not primary side. And the applied voltage on the primary is designated capital letter B with subscript P. So this is the primary side, the secondary side. Okay, let's try to take the equivalent circuit diagrams of this. For the meantime, we repair all values to primary. Okay? We will not do it primary and secondary at the same time. We will just repair all values to the primary. Okay? And as soon as we derive the relations on the primary, we will do something by just using the ratio transformation. So we could take the equivalent of the circuit diagrams referred to the primary, okay? And what will now come out will be the circuit diagram, equivalent circuit diagram referred to the secondary. So as a start, we will compute all or we will derive all values referred to primary. Primary. Meaning to say, so we could merge the primary parameters with the secondary parameters. We will transform the secondary parameters in terms of primary by using the ratio transformation. Right? So if we try to redraw the given circuit diagram, the primary side will still be the same. This is BP. Am I in camera? It's IP, RP, XP. The induced voltage on the primary. We didn't touch anything on the primary. What we will do on the secondary, we will convert all these values referred to primary by using the transformation ratio. Right? So if we try to compute the equivalent RS referred to the secondary or primary, considering RS, we must have to multiply this by A square. I will not prove that by multiplying this one by A square is the correct one, but the next time around, I will derive this one. Okay? So for the meantime, let's accept that to convert all values on the secondary, we must have to multiply it by A square, considering the resistance and the what you call this reactance drop. So to convert this RS now, as referred to the primary, we must have to multiply this by A square. Okay? And so with the X of S, multiplied by A square. For the current, this current IS, if we try to repair this to the primary, okay, we will divide this by A. And here we multiply by A square. But the next time around, I will give you the proof, okay? For the current, for this IS to be referred to the primary, we must have to divide this by A. Right? And for the voltage across the load, we will multiply it by transformation A. So this was originally B sub S referred to secondary, but if we now try to refer this BS here to the primary, we must have to multiply this by A. So you could see the difference? Guys? Right? This is all primary. This is now converted to the primary side values. So if we now try to bring out the equivalent circuit diagram, okay, we could merge now, right? Because primary, okay, we converted all these values referred to the primary. So actually, it seems they are in series already, right? It is like this. The original primary parameters are still the same, RP, XP, IP, okay? These one are the primary equivalent of the secondary parameters. RS is multiplied by A square, XS is multiplied by A square, the current is divided by the ratio transformation, and the terminal voltage here is actually multiplied by A. What do we call this? Unknown to us. We could not see the so-called no load current. But if we try to draw the circuit diagram of that, it will be something like this. Because the no load current, it has two components. It is the excitation current, okay, due to the movement of the flux and the what you call this and the winding, okay. We term to there is a loss and it is called excitation current. And the other loss is actually the hysteresis in eddy current, capital letter I with the subscript HE. So the vectorial sum of the excitation current plus the hysteresis and eddy current loss due to the lamination, okay, that is referred to as the no load current. Okay, so it seems we are having a circuit at the middle, okay, consuming a no load current, and it is designated as I sub N sub L, right? So if we now try to revise the operation, the circuit diagram, this is the revised circuit diagram. Okay, we draw R sub P here, this is X sub P. The equivalent of the parameters on the secondary side referred to the primary are these values here. A square Rs, A square Xs, the current is Is over A, this is A times B sub S. So these are all referred to the primary already. So it seems they are in series with Rp and Xp, right? And if we try to move this one here, before the IP Rp, it's here. Okay? This is IP, originally, the one coming from the transmission line, IP, primary current. The input voltage coming from the transmission line is Vp, right? This is still, I just move this portion here, in here, right? So it bypasses this RPXP, okay? So this diagram is this is the revised equivalent. Okay, let's move to the next circuit diagram. Assuming that the no load current is zero, it is not actually zero, but to simplify calculation or to simplify the circuit diagram, supposing the no load current is zero, what will come out? What will come out? If the no load current is zero, okay, it seems this is gone. But in reality, it is not. But just to simplify calculation, because the value of the no load current compared to the value of the primary current and secondary current, this is actually very negligible, right? So if the no load current is zero, for the meantime, we assume, right? What will come out for the circuit diagram will be this. The no load current was here originally, right? I remove it. Okay, I place it back. So, no load current was here, okay? But on the next diagram, assuming that the no load is current is zero, this portion of the circuit will be gone, right? No more. So what comes out? It's just a simple series circuit. This Rp and E square Rs are in series, and this Xp and this E square Xs are in series, okay? Because we will just combine Rp and this is resistance. This resistance, we combine it as a real part of the impedance drop, and Xp and A square Xs, we will combine it as simply the compressed equivalent of the imaginary part of the impedance drop. So after removing this portion of the circuit here, okay, this is still Vp, okay, this is the primary current. The voltage across this referred to the primary is A times B sub S. Okay, so if we now try to compress this one, compress this. Okay, we compress it. We combine Rp and A square Rs. So we term this one as capital letter R with the subscript E, again with the subscript P, meaning the equivalent resistance referred to the primary is actually the sum of these, the real part, Rp plus E square Rs, and the imaginary part of the impedance drop is actually Xp. Am I on camera? Xp plus E square Xs. That's why I place it here, capital letter X with the subscript E, again with the subscript P, meaning subscript P, it is referred to the primary, right? Because originally we all refer the values to primary, right? So this one, this is now the single equivalent. We compress it. That's why our title for tonight is Equivalent Circuit Diagram of Transformers. Meaning these complicated things, as we move on, could be compressed as a simple series circuit. The explanation is this, right? How come we compress it? Okay, so we combine this one, resistances, we combine the reactances, so it will just be simply two circuit parameters now. The single equivalent resistance referred to the primary, and what they call this compressed equivalent of the reactance referred to the primary, and the current passing will be IS over A. Right? It is IS over A. This is still IS over A. Right? And this is BP, and this is EBS. Okay? You know the significance of this? If we know these values here, and we know the compressed equivalence of the resistance and the reactance, we could compute for this one immediately without passing through the vector diagrams that we did the last time around, the complicated thing. So actually, the equivalent circuit diagrams makes the calculation simpler, right? By assuming that the no load current is zero. But it is not zero, but as a percentage of the total primary current, it's very small. So actually, we could eliminate it from the calculation. So the equivalent circuit diagram of this one, referred to the primary, will be this one. Okay, referred to the primary. So take note of these equations here if it is referred to the primary. And if we try to convert this one now, referred to the secondary, okay, we will start with here, then we go again from the previous part of explanation. But to simplify it, we will just use this one, then we will convert all these values referred to secondary. So the equivalent circuit diagram referred to secondary now, if we try to take the equivalent of this referred to the secondary, okay, we will divide all voltages by A. Okay, this is BP. So it will be referred to the secondary, we will divide it by the ratio transformation. So actually, that's the definition of a so-called transformer. Okay? You could actually manipulate the values by using the ratio transformation. So if we try to refer this BP here, referred to the secondary, we must have to take the value of this, okay, divided by A, because this is actually PS. Right? And for RE now, capital letter R with the subscript E, again with the subscript S. Subscript S meaning it is referred to the secondary. It will be RS. It's the opposite of this one. It should be RS. Since we are computing the equivalent resistance referred to the secondary, we will start with RS. It will be RS. We will take the value of the primary resistance. For it to be converted to the secondary side, we divide it by A square. We divide it. On the primary side, we multiply, right? But on the secondary side, we will divide this by A square. Same so with the reactance. The equivalent reactance, okay, X with the subscript A, again with the subscript S, meaning S is referred to secondary. It's the same, we just replace the parameter. XS plus the reactance on the primary. For it to be converted to a value on the secondary side, we will divide it by A square. We transform it by dividing it by A square. Next time around, I will show you the proof of this, okay? And the current, okay, instead of IS over A, because we are now on the secondary side, this will just be simply IS, right? So this is BS, this is IS. All these values now are referred to the secondary. This is now BS. No more A, right? No more A. It's just simply BS, right? And the load impedance is still the load impedance. Okay? So the most important thing here for this lesson will be this circuit diagram here plus these formulas the circuit diagram plus these formulas. Because if we brought out a calculation using the primary side, there will be a result. And if we brought out a result by using the secondary side, okay, it will still be the same result. Okay, that's it, guys. So this original circuit diagram could be converted to this. As referred to the primary, this will be the single equivalent. And as referred to the secondary, this will be the single equivalent. The next time around, I will give you the proof that the product of A square RS, if we try to refer this to the primary, I will show you how come there is an A square for it to be referred to the primary. Okay, that's it, guys. This is Professor David J. De Los Reyes. Good morning from Los Angeles. Our topic was the equivalent circuit diagrams of transformers, referred to the primary and referred to the secondary, and these are needed in the calculations of the open circuit problems and short circuit problems for transformers. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.